Okay guys, this video is the second part of a repair on the Sapphire HD7950. I made the first part of this video back in November, and I had to wait for parts which have now arrived, so this is the second one. It's a good idea if you didn't watch the first part of this to go and watch it before you watch this one, and then I'm sure you'll properly appreciate the repair. Alright amigos, this is a graphics card, HD7950, and this is one of the ones that I bought in the batch. Well, I have 13 graphics cards in total from eBay, spares or repair, and this is one of the 10 that came together. And this was the subject of a video in November, and basically what transpired from that one is that there's a Mosfet missing from here. So this is the RAM power supply, the memory phase, and this is all the vehicle, and there's a Mosfet missing from here. And we also had an open circuit resistor as well on the other side of the board, which is, I'm just trying to figure out where that actually was now. I'm sure I can find it. Yeah, they were here. But let me just zoom down and we can actually have a look to see where we got to with this one. So we can see now this is the actual card. It's HD7950 3GB DDR5, DDR3, whatever it says, DDR5 I think. So yeah, this is the card, and I'll link the first video so you can have a look. But basically we have a controller chip here that is driving the memory phase. So this has a high side and a low side, well, two low side MOSFETs and one high side, and this drives the gates. This is the pulse width modulator controller, and it comes via these two resistors here. And this one actually says 1R0 on it, but it was open circuit, and this one actually measures 0 ohms. I'll get it under the microscope, you'll be able to see it even better. Okay, you can actually see it a little bit more clearer now as well, actually. So yeah, this is the model. It is DDR5, yeah, 3GB. And this chip here, 5230, is actually an NPS5230, and that's the pulse width modulator controller that drives the MOSFETs for the memory phase. And these are the two resistors. And this one was reading 0 ohms, and this one actually had marked on it 1R0, but I replaced it with another 0 ohms, thinking it was probably supposed to be the same as this. The resistor actually read open circuit, that's why I replaced it. It was open circuit, this resistor. But having done that, and we then powered it up and it made no difference, and I tracked those resistors out a little bit further, and I then found that they come to here. I'm just going to focus on it, there you go. That they come to here. So these are your two low side MOSFETs, and this is the high side MOSFET that's missing. This had already been taken off the board before I got it. And you'll notice here there's another 1R0 resistor, and I tracked this through. So effectively, I think this pin 4 is the gate of each of these MOSFETs, and they connect to this one. And then the one on the other side of the board, which I replaced with the 0 ohm, this one, yeah, this one, that actually goes to the gate of the missing transistor. Let's just find out where we were again. Yeah, there we go. Gate of the missing transistor. So that's how it's wired up. I can show you that actually on the piece of paper, and then it'll probably come quite a bit clearer. So this is the high side MOSFET. This is the one that's missing, okay? And although it was missing, I actually went onto Badcap's forum, and I found that this actually is the correct part number, 4C10N. The 0 ohm resistor I've shown here, 0 ohms, 0 ohms. So this effectively is your upper gate or high gate drive coming from the pulse width modulator. This is LG, lower gate drive, yeah, which goes to both the low sides, coming again from the pulse width modulator controller. And what I didn't quite figure at the time and this is where it was a 1 ohm and I put a 0 because this one was 0, is in actual fact there's another resistor after that one, and one is on one side of the board and one's on the other side, and one's there and one's there, yeah. In the case of this one, this is the 1R0 and this is the 0 ohms, okay. And if you look at the other side, this is the 0 ohms and this is the 1R0 on the other side of the board. So that's how it should be. So I need first to put another 1 ohm resistor in here. If you look where these resistors actually go, by the way, I think you see it on this. Yeah, you probably can actually. You can probably see that there's some quite thick tracks on the board coming this way. And I think effectively these and the one on the other side here are actually current sense resistors. Because when you're driving the gate of a Mosfet at the high frequency, which this obviously is, 50 kilohertz or 100 kilohertz, some current will flow through that. This acts like a capacitor, and I'm guessing they're either sensing the current or they're sensing when the current stops, effectively when the Mosfet's off. But either way, without reverse engineering, I know I need to put another 1 ohm back in there. That's the first thing I need to do. So where we came to the end of this video, I said I was going to order a new Mosfet to put in here, 4C10, and I actually ordered 10. And I said I was going to order the controllers, NPS 5230. And for some reason, when the parts came, I realised I forgot to order these. I don't know why. Somehow I forgot to order them, and I ordered those. So let's have a look at the circuit and see if we can figure out what's actually caused the failure. My original theory was possibly that this MOSFET went short 12 volts to gate, and the 12 volts come down here into the controller. This is why I thought the controller might be damaged and what blew the resistor. But I don't actually think that's the case. So let's measure some resistances. Let's measure from this gate to ground and from these gates to ground. If they measure about the same, we can say that there isn't a short inside this chip, okay? So let's get to the board again and let's have a look. I'll get the meter so you can see it, and let's have a look at what we have there. So I have the meter there, you can see it. These are the low side MOSFETs, having the focus has gone out on its own while I was just setting the meter up. It's back, there you go, magic. So these are the two low side MOSFETs, and if we read, so we go one end to ground, and this side is effectively the VCore, sorry, not the VCore, the VRAM. So the resistance of VRAM, yeah. So that's the resistance of the memory. You can see it here and here. Okay, about 62. The other side of these two, because these are the low side, will go to ground. Yeah, and the gate is actually here. So this gate here is actually reading, and I'll just make that window a bit bigger so you can see the range. It's not reading 49 ohms, it's reading 49 kilo ohms. Let's get that a little bit bigger so you can see that. Yeah, I don't know why that focus just likes to move. Okay. You can probably see it a little bit clearer. So, this here is reading 0.3 ohms. That's ground. 462 ohms, that's the VRAM. And this is reading 49 kilo ohms. So that's obviously be the same on both of them because they're connected together. Yeah, that's effectively, because the MOSFET itself doesn't read any resistance, that's the resistance of the driver chip on the lower gate drive. The upper gate drive, I believe, is starting at, I think, pin 1 at this end. It's 47 kilo ohms, so that's very close. So we can say that there isn't a short inside that controller, which is what caused the 1 ohm resistor to blow. So let's have another look at it and see if we can figure out what might have actually happened with this. And to understand what might have happened, let's have a look at a MOSFET. Okay, so this is a MOSFET. This is actually one of the replacement ones, 4C10N. So this is one of the, I bought 10 replacements because they're a bit cheap. Okay. So with the MOSFET you have a drain and a source, and if we connect from the drain to the source, the MOSFET is open circuit because the MOSFET is off. Okay. Now if I just touch the gate, which is here, with my positive meter, yeah? Watch what happens now. The MOSFET's turned on, it's like a short circuit. And it'll stay turned on until I touch the gate with the negative lead, it'll switch off again. So again, we'll just touch it with the positive, yeah? And it switches on. Now notice the MOSFET stays switched on, even though there's nothing touching the gate, yeah? And it's still on. Why is that? Well, basically the gate of a MOSFET acts like a capacitor, like a very small capacitor. And it holds a charge effectively, even though the capacitor is like picofarads, yeah, it's a very low value. It holds a charge. You can see this is still switched on, and it'll stay switched on until I switch it off. And now it's switched off. Okay, so let's go back to our circuit now, and we can understand now why this is relevant and what's probably happened here. Okay, so this is our circuit, and I was debating on the previous video, is there a short in here? So effectively, this goes short and it all flows through here, 12 volts, straight into here and blows the chip. But we can see the resistance here is about 47 kilo ohms, and here is about 49 kilo ohms. So I suspect this chip is probably okay. So why did the MOSFET go short? Why did the resistor go open? My best guess, and this is a good theory, this is sound theory, is this. This resistor failed. It just failed. It went open circuit. Okay, maybe just a microscopic crack in it. The board's flexing with heat, and it just goes open circuit. Now you might think this chip effectively is driving positive pulses into the gate here to turn the transistor on, turn the MOSFET on and off rapidly. And this one here is also driving positive pulses, yeah? So what happens when this resistor goes open circuit? No more pulses get to here, yeah? You'll think, okay, that's gone open circuit, so these pulses are now disconnected from the gate, so this transistor can no longer turn on. So effectively no voltage can come out of here, but this can't turn on, so nothing else happens. But that isn't necessarily the case. Look what's happened now. This gate is not connecting to anything. It's just floating. It's just a floating voltage, not connected to anything. And you've just seen that this gate acts like a tiny capacitor, and I can charge it up just by touching my meter probe on it in diode mode, and then it will stay charged, and this will stay turned on. So what can quite often happen, you know, you'll, oh well, the thing's gone dead, so you reboot the computer, try to boot up, you reboot the computer, and it's quite possible for some stray charge to get into this gate, and it's got nowhere to drain to. It has effectively an infinitely high resistance, so that just charges up, and when this charges up, it does what it does when I touched it with the meter. It turns on and stays on. So of course now, when this starts up and it switches this MOSFET on, the power all comes down through here. And remember, there's two of these, so the power all comes through here, and half of it goes there and half of it goes there to ground. So this is now taking twice the current that each of these are, and this will go short. Yeah, this can go short, and that's what I think's happened. It's turned on. This is because there's no drive to the gate. It's floating, and then because it's stayed turned on, when you switch these on, it just pulls all the current through it, and that blows short. And that's what I'm sure has happened here. Not that the power's gone down to here. So this is why, by the way, you should never disconnect the gates, or for instance, take the VRM controller out of the circuit. Yeah, remove that and switch the thing on. Don't. Because you're likely to cause a catastrophic failure where the 12 volts, the high side MOSFETs will go short. The voltage will come through here, but when effectively these are switched off, yeah, because remember these are switching on and off. When these are off, the voltage will go down there, yeah. It's not a good thing to happen. The load ain't going to like it. This one's like 0.9 volt or 1.3 volts. It doesn't want 12, yeah. So never ever remove that and thinking, well, it's okay because the MOSFETs can't turn on, yeah. Hope that's taught you that one, guys. Anyway, so in the case of ours, I think if we replace put the 1 ohm resistor back in so it matches this one, and they both match the same. We'll fit a new MOSFET here, and then let's see if we've got any VRAM. So that's the high side MOSFET. Oops, bit of paper. That's the high side MOSFET replaced. There's no shorts. I've just checked it again. It's always a good idea after you've been soldering these things, just to make sure you haven't caused any more problems, because we've had enough to start with, yeah. So we can just check. So the resistance of the RAM, 56, 50. It'll read a bit lower because the board's still warm from the hot air, yeah. And I've noticed with RAM and GPUs, as they warm up, the resistance drops. As they cool down, it gradually increases, yeah. This is the 12 volt side of the MOSFET. Quite a lot of kilo ohms there. This is the gate. I think it's this one. Just get onto it. No, it's not this one, it's this one. Get in there. I'll have to look down the microscope one moment, guys, so I can see what I'm doing. Let's see. And then I haven't got any glasses on, so I can't bloody see. Yeah, 46 kilo ohms, 46.6. So that's okay. So there's no short circuit. We can go from the 12 volts, which is the same as going from the top of this MOSFET, to the VRAM, and there's no shorts. Okay, so that's ready to try. I mean, I would think I can pretty much predict exactly what's happened with this already. So you can imagine the resistor's got open circuit. This gate has floated, it's turned on, and that's gone short. So somebody's obviously looked at this because this has been removed. So somebody's probably come along, diagnosed the short circuit MOSFET. So they've taken it off the board, put another MOSFET on, and switched it on. And of course, what's happened? The gate's floated down, it's gone short. Now, at that point, having made the mistake once, really, you should then check why is it going short. They've probably taken it back off. Yeah, it's short again. And I think at that point they've probably given up because they didn't find that. And really, if this thing's going short, then this is the next thing to check and make sure you've got a connection from the gate back to the controller. So obviously whoever the guy is who did this isn't as good as you guys are, because you guys know this now, yeah? You guys know this. So this is a mistake you're not going to fall in, yeah? You're not going to fall into that trap. Okay, let's now try the board. I've connected up then on the mining adapter because just it's easy to work like this. I've just put a thermal pad on there for now, because if it powers up I'm not going to leave it on for very long. I just want to see if I've now got VRAM, and maybe even if it bleeps or something, yeah. So everything's ready to go, so let's just push the switch and see what happens. And we have VRAM. That's a good sign. And it stayed on. That's quite stable. Okay, so that's given us that. And we get a bleep, and are we going to get a picture? I think so. Yeah, we have it. We have it. Okay. So let's put this one back together, and let's put some software on, run fur test or something, and let's give it a proper test. Yeah. And sorry, I was slightly shot for that one, but there you go. Okay guys, so there we have it, running Furmark. You see the GPU temperature, fine. What's it giving us? 42 frames a second, probably quite normal for one of these cards at 1920 by 1080. Running quite sweet. So it's all back together there, you can see. So yeah, I think we're going to have to call that one a success. I'll make sure to link the previous video. I suggest if you haven't seen it to watch them both, then you'll actually appreciate this repair and what was done basically, and how we got to where we got to. Okay guys, so there you go. Let's give us a score point. So I'm sure somebody can tell me if this card is actually working correctly. I mean, this machine's only a 4th generation, probably, I don't know. Let's see what the machine actually is, shall we? Let's go and have a look in Specky. It has just a normal mechanical hard drive, if you like, it's specky, so let's have it, you can see what the machine actually is. Yeah, i3 4150 processor. There you can see the 3 gig HD7900 Sapphire all working. Okay guys, hope you enjoyed that one. Adios amigos, hasta luego.